Hi students, now we'll move on to our next topic, union. So union is a structure all of whose members share the same storage. See, already we have seen what is a structure, right? So structure is going to be a collection of heterogeneous data items. So union is also going to be a collection of heterogeneous data items. But here what is the difference is it is going to share the same storage, right? So the amount of storage allocated to a union is sufficient to hold its largest member. So the amount of memory is going to be the size of your largest member. In that member itself I am going to store all my members, right? So at any given time only one member of the union may actually reside in that particular storage. Since I have got only one location, in that location I want to store all my members, right? So a union is identified in C, right? So how I am going to define it? With the help of a keyword called union in the place of struct, right? And all the methods for declaring and accessing the union are going to be the same as your structure, right? So what is a syntax? So again I have union is a keyword. So this is going to be my keyword and this is going to be my tag name. Already we know what is the purpose of tag name, right? So these are all going to be my union members. There we have seen member, right? The structure members. These are all going to be what? Union variables. There we will call it as structure variables, right? So here we will call it as union variables. When you see, there is no difference at all when you see the declaration part, right? The only difference is going to be the storage, right? So we will see the example, right? So let us move on to the example. How can we declare a union? Union, mixed, char, letter, float, radian, int, id. So I have used all the three types. So it is going to be a collection of heterogeneous data items, right? So union is a keyword, mixed is a tag name, and these are all going to be the members, right? And I have a semicolon at the end, right? I can also declare my variable here, or else I can put a semicolon and then I can write my declaration here. So union mixed var, right? Now this is going to be my variable. How I am going to access my member? Variable dot the member name, like as usual how you do it in the structure variable dot the member name, right? But the only difference you have got here is, assume that the int occupies 2 bytes, float occupies 4 bytes and character occupy 1 bytes. Generally we'll have, right? In some cases your int also occupies 4 bytes, right? But here you assume that int occupies 2 bytes, character 1 byte and float is going to be 4 bytes. So which has got highest? So here character is 1 byte, float is 4 and int is going to be 2 bytes, right? So here which has got the largest? Your float has got the largest. Float has the largest size, right? So that size will be allocated here. When you see 1000, 1001, 1002, 1003. So totally 4 bytes of memory has been allocated. Is that clear? So 4 bytes, in that I will store all my members. So I will store float, I will store char, I will store int. But at a time only one member I can store. I cannot access all the members at the same time. That is the difference between your union and structure, right? So union is similar to a structure except that all members in it are stored at the same address in memory. Only one member can exist in a union at any one time, right? So only one member can be present at any one time, right? So now the union can also be the member inside my structure. We already have seen a structure within a structure, right? So similarly union is also going to be a structure. So I can use union inside my structure, right? For example, if you take this a temperature, structure of temperature, Now I'll tell you the real applications where we can use union, right? So here we are going to use either wind or heat. It cannot be both at the same time. So I can use union instead of a structure. So I'm going to store either a value of wind at a time, or else I'm going to store the value of heat at a time, right? So in that case you can go for using the union instead of a structure. In case of structure, for these two things a memory will be allotted, but here only one memory 4 bytes will be used. Either I can store wind value or else I can store my heat value, right? Now, how to access and initialize the members of a union, right? Already I told you it is going to be same as your structure. So a structure, a union variable dot member, that is what we have written, the variable dot member name, right? Now we'll see one example related to the union, right? Hash include stdio.h, hash include string.h. Here I have declared an union, a data where I have int I, float and character array, right? Now I have a main function. In the main function I have declared a variable for my union data var. So var is going to be what? This is going to be my union variable, right? This is going to be the tag name of union. This is a keyword, right? Now you printf size of union. If I take the size of this variable, the output generally in case of your structure, if you take, it will take 30 plus 4 plus 2, right? If it is going to be 2 bytes for integer. So 30 plus 4, 34, 34 plus 2, 36 bytes will be there, right? Usually, if in case of your structure, because it will allocate memory for each and every member. But here when you take a size of your var, right, it is going to give you only 30, because the largest member here is going to be the char string 30 bytes of memory is being allotted. So the size of union will be 30, right? Now we'll move on to another example program, right? So hash include stdio.h, hash include string.h. Again we'll use same union datas, int I, float, char, semicolon. Now int main, here I am declaring a variable, right? Now data.I, data is my union variable, datas is nothing but my tag name. So here I am accessing the member. How I am accessing the member? Union variable dot I, the member, equal to 10, data dot f is equal to 10.5, right? Here I am using the string copy method to copy the string to data dot str, right? So I have done all the initialization here. Then I am printing the value. Now if I print the value, right, what should be the output? Data.I means it should print 10. Now F means it should print 10.5, and then here it should print C programming. This will be done in case of your structure, right? But when you take here, you will have some garbage value for I and F, because it has been re-returned. The memory location has been re-returned with a new value data.str. So only the latest value. What is my latest value? Data.str is my latest value. Only that value will be present here. Remaining two values will not be there. That is why we are telling that at a time only one variable can be accessed in union. Here I am printing all the three values at the same time. I have initialized all the three values, right? So here I have initialized 10, I have initialized, the 10 will be overwritten with 10.5, and this will be overwritten with what? C programming. That is why I have got some wrong values here, right? To indicate that only we have taken this example, right? Now if I want to print it separately, see here I have assigned the value to I have assigned the value to f, and after assigning all the values only I have started printing, right? But if I want to print my values, right, in that case what I can do is I can just var dot I is equal to 10, and immediately I am printing my I value. Then var dot f is equal to 10.57, I am immediately printing the value. And string copy, here I am immediately printing the value. In that case your output will be correct. Is that clear? So at a time only one values can be stored and it can be printed, right? Now we'll see one more example. Now when you see here union test, I already told you test is going to be a tag name. These are all going to be the members. It's going to be the union variable int main. Here I have assigned var dot I is equal to 65. So I have initialized only one variable here. Then I have printed var dot I, and then I have printed var dot C also. Now you already know that integer is going to occupy how many bytes? It is going to occupy 2 bytes, right? So I'll have the value of 65 here. Is that clear? So in 2 bytes I am going to have the binary value of 65, right? Now when I want to print the character %C, what it will do is the 65 will be converted to your character value and that will be printed. Is that clear? Even though I have not assigned the value for my character, since I have assigned the integer value and it is matches, so I will print the value of character as A, right? But if you take in the reverse order, for example, if you take var of I is equal to 145 and if I write var of C equal to 273.85, then in that case this will override the value of 145 and this, here the I value will not be printed. Is that clear? Right. Overlays the assigned value to var C, overlays the value assigned to var dot I, because C, your character can accept only 1 byte. The 1 byte is going to be 0 to 127. It will not take 273.85. So it will have some incorrect value for your I, as well as you will have an incorrect value for your character. Is that clear? Right. Now we'll move on to a difference between structure and union, right? So because both the things are going to be the same, so what is the difference and why you need to go for a union? Now when you take structure, a separate memory location is allotted to each members of the structure. So here I told you, for if I take int I character C in case of your structure, I have a separate memory for I have a separate memory for character. But union, it is not going to be that. Whichever has got the largest member, the size of the largest member is going to be the total memory allocated for your union. And here struct is a keyword used. Here union is the keyword that is being used. And size of the structure is equal to sum of size of all the data members, right? And here the size of union equal to size of the largest member. And all the structure can be accessed at any point of time. If I want, I can use structure variable dot member name. I can print it. I can do it in any order. But here only one member of a union can be accessed at any point of time, right? Because it is going to share the same value, right? And then this is going to be the syntax for your structure and this is going to be the syntax for union. The difference between structure and union is going to be a very, very important question. So please go through it, right? Right. What we need to do and don't for unions. What I can do with unions, what I should not do with unions. So a union variable can be assigned to another union variable. Already we have seen in structure also, right? Structure variable can be assigned to another structured variable of the same type. So that is also possible in case of union. Can be passed to a function as a parameter. We have already seen how to pass a structure to a function. Similarly, I can pass this to a function as a parameter. The address of a union variable can be extracted by using the ampersand operator. This I will tell you when we move on to the pointers. So address of a union can also be obtained, and it can also be passed to a function. A function can accept and return a union or a pointer to a union. That we know. If the function can accept an argument, it can also return a union as a return value. The size of union is equal to the size of the largest member, right? Largest member. And don't perform arithmetic or logical operations on union variables. Like your structure, I should not perform any arithmetical or logical operations on union variables, right? Thank you.